We're sitting here at the point of Buckwai, just the shoreline side of the Brochabushy, which we'll look at probably later. But I'm here as a geologist. You, Adrian, are what we call yourself these days.
I'm a landform man, I'm a geomorphologist, so I'm interested in scenery.
Yeah, and how rocks interact with the scenery, weathering and erosion.
Yes.
And that's why we're here, because we can get quite a good sampling of general erosion from cliff lines to shore platforms. I've taken you up here to show you the full cycle of the lake beds in Lake Orkney. Starting from deep water laminite containing fish remains at the base here, coming up through harder silts and sands, right up to a ridge of solid sandstone, river sandstones, and then into another fish bed. These cycles are about 12 to 14 meters in thickness, and they repeat all across the shore here. And this repetition, I believe, gives us the form of the shore erosion that we see.
We're looking at the sandstones just now. So John, what do you reckon the dip of those sandstones is?
Yeah, probably about 17 or 18 degrees.
Well, that's pretty exact. So inclination is in that direction, and the individual beds are 10, 20 centimeters thick, and they're giving us this really quite striking pattern, John.
Yeah, it differs. What we see here is the development of the sawtooth, going from slightly softer silts down here to harder sand along the ridge there.
And the thickness of the bed seems to make a difference as well. So the thick beds are giving us the steps.
Yes, that's really probably due to the strength of the wash from the sea coming in, and they're able to lift only certain thicknesses.
Okay, so we've got here a thick bed of sandstone, and the waves are attacking this rock, but it's pretty resistant. So how does the wave water actually get in here? Well, we've got the inclined bedding planes, and we can see those here as well. These are lines of weakness, but we've also got these vertical cracks. What are these, John?
Well, these are joints caused by tectonic movement in the rocks, where they're bent slightly, and this is a very brittle rock, and we end up with brittle fractures within this.
When the waves come in over the rock here, they bring with them quite a lot of mass transfer and quite a lot of fluid flow, which can get into these cracks into the rock. And we can see that at this little step here. Beneath these rocks, there are open cracks. So the wave water gets in underneath the rock, and it's flipped out of position. They then become very vulnerable to transport by the waves. And the wave energy here is really considerable. We're fully exposed to the waves from the southwest and the Atlantic, and so the waves are washing across the platform, and they're moving some really big blocks like this one here. So this rock surface is really smooth, and there's no lichen on it at all. And what's happening here is that the sand and the gravel, and indeed the boulders, are being moved up and down across the surface by the waves, and they're abrading its surface. Another process of wave erosion. So we've got a small cliff here at the back of the shore platform, and we've got a series of sediments exposed, and they're quite interesting because they tell us about the recent geological history of this area. So when we go up to the top, we've got this sand, and you can see that the sand has got these upstanding blocks in it. That's probably archaeological material. That's probably a small kist for burial. And then below the sand and the archaeological layer, we've got this rubble, these big blocks of sandstone. And we can see that some of the blocks seem to be flat in this, they seem to be inclined, and we get the impression they've moved in this direction. Well, the thing that moved them was probably the last ice sheet that came across this way sometime between 20,000 and 15,000 years ago. So this is a glacial deposit from the Ice Age. And then we get down onto the rock. But the rock is in a terrible state. It's very, very badly weathered. It's probably rotted down over some many thousands of years to get into this state.
This oil painting by local artist Ian McInnes shows the wave regime at Yesnaby. The rocks here are lake-deposited flagstones, and you can see, even in their artistic depiction, the lifting of the slabs at the top of the cliff, which must be related to the passage of wave water over the top. The wave energy is concentrated at the base of the cliff, and even on what is here a relatively calm day, the wave water is reaching above 10 meters. The artist is showing us the bedding in the rocks, the vertical joints, and in the cliff face we have a jagged profile where the individual strong and weak beds of rock have been exploited by the waves. The longer vertical fractures forming chimneys opened out into clefts, geos, and caves. This is Marwick Head in Bussey and demonstrates a different type of erosion where undercutting by caves leads to collapse of the cliff face. Directly below the Kitchener Memorial, we can observe the most recent cliff collapse, about 8 to 10 years ago, when the whole face slumped into the sea. No evidence of it remains now, so all that rock has been transported out to sea by wave action. Here we have Langio at Northside Bussey. This is a wave-scoured geo formed by erosion along a north-south fault line. It started as a deep cave originally, but over time this has led to the collapse of the cave roof and removal of debris out to sea. The name geo is an Old Norse word which refers to these slots in the cliff. They are particularly striking features of the coastline of Orkney and Shetland. Most are aligned along lines of weakness such as faults. A fault line of movement in the rock contributes to a great deal of crushing and breaking. This makes the rock split up into small blocks which are then easily removed by the waves. On the outer southern side of Scale Bay, we find a formation known as the Hole of Row. Again, Here we have all the characteristics one associates with wind and wave action. In this case, one can observe, forming along a fault line, what would have been originally a geo, penetrating from the other side of the cliff. This eventually comes all the way across the headland. The rock above this hole is ready to collapse, and this would eventually produce a separated rock castle on the seaward side.
We're at Yesnaby, on top of the cliffs, on a calm day in June. But Colin Keldy was here with his video camera on a very stormy day earlier this year, and he painted a very different story, because his video shows us that the spray and the wave water is getting up onto these cliffs. And that's impressive, because I'm standing 30 meters above sea level. We're in what looks like a dry riverbed, but there's no stream here, and yet there's clearly been a strong flow of water down this little valley. And what appears to be happening here is that the waves are crashing over the cliff, and the wave water, some of it thrown into the air, is landing on the cliff top and then draining away down these gullies. This would be a very dangerous place to be when the storm seas were running. Loads and loads of water coming over the cliff. At Yesnaby, just behind the top of the cliffs, we have this beautiful meadow of sea pinks. And these are growing in this stony, sandy deposit, and it's very clearly a layered deposit, so it is a sediment, but where does it come from? Well, the individual fragments are really quite angular. They're all from the local cliff rock. And what's probably happening here is that all these stones are a result of being thrown to the back of the cliff by spray. So when we have the waves hitting the cliff face, the waves climb up and you get a spout of spray going into the air, and any debris in that spout will then rain down some distance inland, because the winds are really strong, 60, 70, 80 miles an hour.
Hi Adrian, come down here.
Well, this is a remarkable accumulation of boulders on the cliff top here, and you've been coming here for many years.
I have indeed.
And you've seen some changes.
Lots, particularly in this area here, over the past 2 years. There's been a big change.
2 years.
Yeah, with the big flat slabs,
Yep.
imbricated up above behind you,
Yep.
that you've just come over, and also these igneous rocks from the trap dike, the trapezoid
These ones
pieces,
here,
yeah. They've all come, in my opinion, from the sockets over on the end of the dike.
All right, so these things are coming from sockets on the cliff top.
Yeah.
So we've got some pretty big boulders moving here. This one is 1.5 meters across, so we're dealing with many tons in terms of weight.
I think what we have to think about, though, under the trap dike that runs up here, there's a big cave system and a lot of hydraulic pressure pushing upwards. So they could be being lifted up off the sockets. We've been down there before where we see the water bubbling up every time a wave comes into the cave.
Well, if that was the case, we'd need to go over the cliff edge and find some sockets. Well, we can't do that today, so let's see what we can find on the cliff top. So John, the answer to where all these big blocks of rocks have come from probably is to be found here.
Agreed.
Yeah. So we're on the cliff top. We're now about 24 meters above sea level, something like that.
Yeah.
Couldn't say for sure. And yet we're seeing all these very fresh rock surfaces. It looks as though we've lost really big plates of sandstone here. When do you think they came away?
Well, as we've said before, I've been here many times, and this is all very fresh.
Okay.
I suppose 2 years ago when I was here, they were fresh, lifted. They're now weathering slightly.
Oh yes, just a little. So these blocks have been exposed over the last few years, and we see around us evidence that the waves are getting up onto the cliff top. So it looks likely that the blocks themselves are lifted by waves.
Can't disagree with that as a hypothesis.
Okay, well let's have a look for some evidence as to what the process is that's lifting the blocks. We find clues as to where the blocks are coming from on another part of the cliff top. We've got this really fresh rock surface here. It's a surface which has been exposed over the last few years, and it appears as though the surface layers have just been peeled off. So what's going on? We know that the waves are getting up here because we've got big blocks across this bit of the cliff top. Here we have the bedding planes in the sandstone, and you can see that this bedding plane here has been opened out. Indeed, you can see this vertical crack here, really rather irregular. The rock is broken. And what seems to be happening here is that we're getting wave water in this crack under very high pressure. And once the water enters this crack, if the wave water continues, then it can lift the whole of the rock surface. This slab of rock is in danger of coming away in the next big storm.
Central to the discussion in this presentation is the concept of an air and an ice, which is a geomorphological feature present all round the coastline of Orkney and Shetland. These words originally derived from Old Norse, where an air is a shingle beach and an ice is an inlet of the sea. They commonly occur together when sea level is falling and the ice is trapped behind a storm beach or air. In sheltered areas, such as southeast Stronsay, the air and ice, named Straina water, consists of a small loch or ice backed by a grass-covered cliff containing waters between 2 and 3 meters above present high water datum and separated from the sea by the air. At Bursey Bay, we have a low, rocky shoreline. This shore platform extends for around 200 meters seaward at low tide. This is typical of many parts of mainland Orkney and the North Isles. This air photo shows a day on which the waves are coming in from the west or southwest and entering the bay. We can see the wave crests, and we can see that this is a very exposed location to the direction from which the highest wind speeds come. It is highly probable that at some time in the past there was a connection between the point of Buckwai and the Broch. This connection was probably a natural barrier or air and tentatively dated to around 1100 years ago.
So this would be similar to the air that we saw at Marwick?
Yes,
All right, so a similar form.
With the ice behind it.
So it was here about 1,000 years ago, and it's more or less gone now. Why is it gone?
Sea level has risen.
Oh, okay.
You know, and all the processes we looked at down on the beach have occurred and flattened.
Do we know how much the sea level has come up over the last 1,000 years?
Yes, my best estimate is about 2.8 meters.
That's quite a lot.
It's sunk since then.
All right, okay.
So it's relatively high over the, from about 1,000 years ago to 3,000.
Right, so it's dropped.
Yeah.
So that drop in sea level has meant that the waves have attacked the
causeway, yeah, the old air. Orkney's Earl Thorfinn the Mighty, half-brother of Macbeth, was a major sea king, and no doubt would have had a large number of shallow-drafted longboats under his command. These would have been anchored in the bay behind the Aire in the quieter summer months. These vessels are hauled ashore for winter, providing roofs for the houses on land. The archaeology of the palace grounds on the Broch show the top end of Thorfinn's slipway, dipping down to the centre of the bay behind the causeway. We have not examined the deep water entrance to the harbour to see if there is a man-made element to it. That remains for further examination.
So it's been a tremendous trip. You've taken me up to Bursey. We've seen a low rock coast and the processes operating on that coast. You've shown me how the rocks and the structures are controlling the shape, the detailed shape of the coastline. And then off we went to Yesnaby, to the high cliffs, where the big waves are coming over. And that's very, very spectacular scenery. So thank you so much for showing me this magnificent coastline.
Yes, and thank you for showing myself and the audience this dynamic situation we have on the west side of Orkney. It's a very complex story. We've only just touched on it, but thank you very much and hope you can come back again, Adrian.
Thank you.